Hello everyone. In the last session, we have discussed some of the basic concepts of FET. In this session, we will be discussing about some of the basic concepts of BJT, that is bipolar junction transistor. These are the symbols of NPN and PNP transistor. This particular slide shows the internal structure of NPN and PNP transistor. Okay, here BJT, as we can see from the diagram, is a three-terminal device having two junctions and three portions known as emitter, base and collector. Okay, here base is lightly doped, emitter is heavily doped and collector is moderately doped. When you compare the sizes of different regions, base region is very thin, collector is the largest. One of the main thing about BJT is that it's a bidirectional device that uses both electrons and holes as charge carriers. BJT is basically a current control device. The current here flows either from emitter to collector or from collector to emitter based on the type of connection. Okay, the main current here is controlled by a very small current at the base terminal. Okay, in case of PNP bipolar transistor, the N-type semiconductor is sandwiched between two P-type semiconductor, whereas in NPN we can see that P-type is sandwiched between two N-type semiconductors. Okay, so in this slide we'll be discussing about different regions of operation of the BJT transistor, and we have taken the example of NPN transistor here. Okay, and there are four different regions of operation: active region, saturation region, cutoff and reverse active region. Reverse active region is not suitable for any application and generally not used. Its configuration is opposite to that of active region. Okay, now we'll discuss what are active, saturation and cutoff regions respectively. First we have active region. In active region, one of the junctions is in forward biased condition while the other is in reverse bias. That is, the base emitter junction is actually forward biased and base collector junction is in reverse biased condition. Okay, in this case the base current IB can be used to control the amount of collector current IC. Okay, therefore active region is used for amplification purpose, where BJT acts as an amplifier with a gain of beta. Okay, and we have an equation given as IC equal to beta into IB. Okay, for this particular region of operation. This particular region is also known as linear region. Okay, and it lies between cutoff and saturation region. Okay, and when we consider normal operation of BJT, it occurs in this active region. Next to that we have saturation region. In saturation region, both of the junctions of the BJT are in forward biased condition, that is, base emitter is also in forward biased condition, base collector junction is also in forward biased condition. Okay, this region is used for the on state of switch, and here we have IC given as ISAT or I saturation current. So ISAT is actually saturation current, and it is the maximum amount of current flowing between emitter and collector when BJT is in saturation region. Okay, since both junctions are in forward bias, BJT acts as a short circuit. Okay, this is one thing that we should know. Next, what we have is cutoff region. In cutoff region, both junctions of BJT are in reverse biased. That is, base emitter is also in reverse biased, base collector junction is also in reverse biased condition. Here, BJT works as off state of a switch. And I think by this one thing that we should note here is, when we want to use a BJT as an amplifier, we'll be operating it in active region. When we want to use it as a switch, we work in saturation and cutoff region. Okay, and yeah, that was about the different regions of operation. Next, we'll be discussing about different BJT configurations. We basically have three different configurations. One is known as common base, then we have common emitter, and then common collector. Okay, they differ in the way input is provided and output is obtained from the transistor. Okay. So this figure here shows common base configuration. As the name suggests, in the common base or grounded base configuration, the base connection is common to both input signal and the output signal. Okay, the input signal is applied between the transistor's base and emitter terminals, while corresponding output signal is taken between base and collector terminals. Okay, so the current gain for this type of circuit is unity or less. Okay, in other words, the common base configuration attenuates the input signal. Okay, next what we have is common emitter or grounded emitter configuration. The input signal here is applied between base and emitter, while output is taken between collector and emitter. This type of configuration is the most commonly used circuit for transistor based amplifiers. Okay, so the common emitter amplifier configuration produces the highest current gain and power gain, okay, of all the three bipolar transistor configurations. This is mainly because the input impedance is low as it is connected to a forward biased PN junction, while the output impedance is high as it is taken from a reverse biased PN junction. Okay, so that was about common emitter configuration. Then we have common collector or grounded collector configuration. In the common collector configuration, collector is common for both input and output. The input signal is connected directly to the base terminal, while the output is taken across the emitter load resistor. Okay, this type of configuration is commonly known as voltage follower or emitter follower circuit. So these were some of the basic concepts of bipolar junction transistors. That's all about today's session. Thank you.